In our day-to-day talk, people will often try to use scientific words to sound fancy or to sound smart. They'll say displacement instead of distance or velocity instead of speed. These words have very specific meanings in the physics context. Distance and displacement do not mean the same thing. Distance is pretty simple. It's exactly what you think it is, how far you went. Suppose we started out over here and we moved 10 feet to the right. The distance traveled is 10 feet. If we started out over here and we moved 10 feet to the right and then 4 feet to the left, the distance traveled would be 10 plus 4, 14 feet. Displacement, however, is only the directed distance from the start to the finish. It's a distance and a direction from the starting point to the ending point. So if we started here and moved 10 feet to the right, then we moved a distance of 10 feet and we do have a displacement of 10 feet to the right. But if we started here, moved 10 feet to the right and then 4 feet to the left, the distance traveled is 14 feet, but the displacement is 6 feet to the right. The Einstein doll ended up 6 feet to the right of where it started. That's what displacement is, from start to finish. So if you start right here and you move this way, and then you quickly move this way, and then you move back here and then back here, if you end up where you started, your displacement is 0. The final position and the initial position are the same, even though the distance traveled was definitely not 0. Distance and displacement are important for determining two other terms that we use, speed and velocity. The average speed of an object is the total distance it traveled divided by the total time. Suppose we went real slowly and I moved 10 feet to your right and it took 5 seconds. The average speed would be 10 feet of distance divided by 5 seconds of time. That's 2 feet per second. The average velocity is the displacement divided by the time. In this case, simply moving 10 feet to the right does give us a displacement of 10 feet to the right divided by the 5 seconds means an average velocity of 2 feet per second to the right. For velocities, we have to specify a direction. Now suppose we started here and moved 10 feet to your right and then 4 feet to the left, and that took 10 seconds. The average speed would be the entire 14 feet of distance divided by the 10 seconds. 14 feet divided by 10 seconds is 1.4 feet per second. That's the average speed. The average velocity, however, would be the 6 feet to the right displacement divided by the 10 seconds, which would give us an average velocity of 0.6 feet per second to the right. So the average speed and the average velocity might not have the same value. In fact, they'll generally only have the same value if you only move in one direction. If you move in more than one direction, back and forth, the displacement and the distance won't be the same values, so the average velocity and the average speeds will not be the same values. So it's very important that in the physics context we use velocity when that term is most appropriate, distance when that term is most appropriate, displacement and speed when they're appropriate. These terms are not interchangeable.